The topic we are going to discuss is chain rule. I am deliberately not telling you the definition of chain rule first. First, I will make you understand how to apply this rule, and then in the end I will tell you the exact definition of chain rule. We have already studied the formula in this column. d by dx of x to the power of n is nx n minus 1. d by dx of ax is ax log a. d by dx of ex is ex log e. Log e is 1. So this formula changes into d by dx of ex is ex. d by dx of log x to the base a is 1 by x log a. Now if instead of a it is e here, then the formula will be 1 by x log e. Log e is 1. So we will have 1 by x. So d by dx of log x is 1 by x. And similarly, we have studied the formula for trigonometrical functions. Now, first of all, I will tell you how these formulae change on applying chain rule. And then I will take up the trigonometrical formula. Now, what the chain rule means: if a formula valid for x is used for fx, we have to multiply the result by f dash x. If a formula valid for x is used for fx, never forget to multiply by f dash x. For example, d by dx of xn is nxn minus 1. Now this formula is used for fxa. d by dx of fx to the power of n. Then this will be n fx to the power of n minus 1 into f dash x. This term will be extra. d by dx of a to the power of x. Now formula is d by dx of a to the power of x is ax log a. If this formula is used for fx, then it will become d by dx of a to the power of fx will be a to the power of fx log a into this term will be extra, f dash x. d by dx of ex is ex. d by dx of e to the power of fx will be e to the power of fx, and this term will be extra, f dash x. Never forget to multiply by f dash x. If a formula valid for x is used for fx, never forget to multiply by f dash x. A formula valid for x is used for fx, never forget to multiply by f dash x. d by dx of log x to the base a is 1 by x log a. If this formula is used for fx, d by dx of log fx to the base a, it will be 1 by fx log a into f dash x. d by dx of log x is 1 by x. d by dx of log fx will be replace x by fx. So this will be 1 by fx and multiply by f dash x. Replace x by fx and multiply by f dash x. This is the chain rule. Now for trigonometrical functions, we have already studied these formulae. d by dx of sin x is cos x. d by dx of cos x is minus sin x. d by dx of tangent x is secant square x. d by dx of cotangent x is minus cosecant square x. d by dx of secant x is secant x tangent x. And d by dx of cosecant x is minus cosecant x cotangent x. Now if this formula is used for fx instead of x, sin of fx will be cos of fx. And never forget to multiply by f dash x. This will be d by dx of sin fx is cos fx into f dash x. d by dx of cos x is minus sin x. d by dx of cos fx will be minus sin fx into f dash x. d by dx of tangent x is secant square x. Now d by dx of tangent fx will be secant square fx into f dash x. d by dx of cotangent x is minus cosecant square x. If we replace x by fx, it will be minus cosecant square fx into f dash x. This term will be extra. D by dx of secant x is secant x tangent x. This will be d by dx of secant fx will be secant fx tangent fx into f dash x, and similarly this function fx is generally referred to as an inner function. This is an inner function. And chain rule states that d by dx of sine of fx is cos fx into differentiation of inner function. So you can also remember the chain rule as never forget to multiply by the differentiation of the inner function. In all these cases, we have multiplied by the differentiation of the inner function. If instead of x we have an inner function, then never forget to multiply by the differentiation of the inner function. If this inner function is x, then differentiation of x will be d by dx of x is 1. Then this will in all the cases be 1. Differentiation of inner function will be 1. You can remember the chain rule as if a formula valid for x is used for fx, never forget to multiply by the differentiation of the inner function. Now I will take one example of each formula to make it clear that how this has to be used in questions. Now first is d by dx of sine x whole cube. Now instead of x we have sine x whole cube. That is, we have fx equal to sine x, and therefore we will apply the formula this will be n fx n minus 1. So this will be 3 into sine x whole to the power of 3 minus 1 into d by dx of fx. d by dx of fx is d by dx of sine x. We have sine x instead of fx. So formula will be 3 sine x to the power of 3 minus 1 into f dash x d by dx of fx, that is sine x. And this is equal to 3 sine x whole square into d by dx of sine x is cos x. d by dx of sine x is cos x. So this will be the answer. d by dx of 3x log x. Now if in this formula we have a equal to 3 and fx is x log x. fx is equal to x log x. So we will apply this formula. This will be a to the power of fx, that is 3 to the power of x log x into log a. Log a will be 3 into d by dx of fx is x log x. So this will be d by dx of 3 to the power of fx is 3 to the power of fx log 3. 3 to the power of fx log 3 into d by dx of fx. d by dx of a to the power of x is a to the power of x into log 3, and a formula valid for x is being used for x log x, therefore we are multiplying by d by dx of x log x. Instead of x we have this, therefore formula will remain a to the power of x. Instead of x we have x log x. This is this into log 3 into d by dx of, we have x log x instead of x. So this will be the result, and this is equal to 3 to the power of x log x into log 3 into d by dx of x log x. This is product of two functions. So first function into d by dx of log x. d by dx of log x is 1 by x plus second function, that is log x into d by dx of x is 1. Or we can say fx into g dash x plus gx into f dash x. Or you can remember it in this way: first function differentiation of second plus second function into differentiation of first. So this is equal to 3 to the power of x log x into log 3 whole multiplied by x cancel, we have 1 plus log x. So this will be the answer. Now in this question we have e to the power of x, d by dx of e to the power of x is ex. So d by dx of e to the power of tangent x will be e to the power of tangent x. And since we are using a formula valid for x, we are using it for tangent x, we must multiply by d by dx of tangent x. This term will be extra. This formula will be used and we will multiply by d by dx of fx. So this is equal to e to the power of tangent x into d by dx of tangent x is secant square x. So this will be the answer. Now in this question we have d by dx of log 7 into log 7x. So instead of a we are having 7 and instead of x we have this. This is fx. This is fx. So formula will be 1 by x. So 1 by fx log a into f dash x. Formula will be 1 by fx log a into f dash x. 1 by fx log a f dash x. So if you remember this formula, you can apply it 1 by fx. 1 by fx. fx is this much. 1 by log to the base 7 x. 1 by fx log a. Log a is log 7 into d by dx of fx. fx is log x to the base 7. Log x to the base 7. So this will be equal to 1 by log x to the base 7 into log 7 into. Now d by dx of log x to the base 7. d by dx of log x to the base 7. We will directly use this formula. We will be using it for x. So we will directly use this formula. So 1 by x log a. Log a is log 7. Now the formula valid for x is being used for x only. So we will end up the process here. So this will be equal to 1 by, now log 7 into log 7 is log 7 square. First of all write the constant term. Log 7 square into x into log x to the base 7. This term is being written here and log x to the base 7. This is this and these two have been combined. So this is the answer. Now next is d by dx of log secant x plus tangent x. d by dx of log fx. So this will be 1 by fx and never forget to multiply by f dash. 1 by fx into f dash x. So this will be equal to 1 upon fx. fx is this much. So 1 upon secant x plus tangent x and 1 by fx and never forget to multiply by d by dx of fx. d by dx of secant x plus tangent x. So this will be equal to 1 upon secant x plus tangent x into d by dx of secant x is secant x tangent x. Secant x tangent x plus d by dx of tangent x is secant square x. So this is equal to 1 upon secant x plus tangent x into. Now secant x is common from here. We take secant x common and we are left with the tangent x plus secant x. This cancels with this and we are left with secant x. These two cancels and we are left with secant x. So this is the answer. I take up some more illustrations. I will not take up many questions independently for chain rule. I am taking all the questions as illustrations for application of chain rule. So first is d by dx of sine e to the power of x square. Now in the previous formula I illustrated you how to use chain rule once only. Here we will illustrate how to use chain rule more than once or how to use chain rule multiple times. Now here what we see is this is d by dx of sine e to the power of x square. So this is equal to, now differentiation of sine is cos. This will be cos e to the power of x square into d by dx of e to the power of x square. If we apply chain rule, this will be d by dx of sine e x square will be cos e x square into d by dx of e x square. Here it will be differentiation of cos is minus sine log sine x into d by dx of inner function. Fx is this. Instead of fx we have this. So this is the inner function. So d by dx of inner function is d by dx of log sine x. Here it will be, now here we have tangent of fx. So fx is e to the power of sine x. So we must multiply by the differentiation of the inner function. So apply the formula. Differentiation of tangent is secant square fx e to the power of sine x into d by dx of e to the power of sine x. And here it will be d by dx of cotangent x. Cotangent differentiation of cotangent fx is minus cosecant square fx and differentiation of inner function. So this will be minus cosecant square fx. Fx is log sine x. Log sine x into d by dx of log sine x. Log sine x. This will be d by dx of log sine x. Differentiation of inner function. Here it will be differentiation of secant is secant x tangent x. So this will be secant log x to the power of n into tangent log x to the power of n into d by dx of inner function. Inner function is log xn. This will be log x to the power of n. This will log x to the power of n. Differentiation of inner function. So this is will be equal to, now differentiation of cosecant is minus cosecant fx 2x square cotangent 2x square into d by dx of 2x square. Now in all these cases what we have done is differentiation of sine is cos and we have multiplied by the differentiation of the inner function. Differentiation of cos is minus sine fx and we have multiplied by the differentiation of inner function. In all these cases, this is the application of chain rule. But in all these questions what we see is, now again we have to use the formula for ex, differentiation of e fx. Again we have d by dx of e fx. So we will have to apply chain rule again. Once we applied it here, but here again formula for e to the power of x will be used for e to the power of fx, that is x square. So again we will have to apply the chain rule. Here also d by dx of log sin x. Now we have to use the formula for log x. Formula for log x will be used for log sin x. So fx is sin x. Again here we will have to use chain rule. Once we used it here, but differentiation of inner function again involves an inner function, so we will again use chain rule. Here also, once we use the chain rule here in d by dx of e to the power of x. So instead of x we have sin x, so again chain rule will be used. Here also log of x, it is log sin x. So instead of x we have fx. Here also instead of x we have x to the power of n. Here also instead of 2 to the power of x we have 2 to the power of x square. A to the power of x we have a to the power of x square. So again we will have to multiply by chain rule. So in all these illustrations chain rule will be used twice, and similarly you can use it 3 or 4 times. So this will again be equal to cos e x square into d by dx of e to the power of x square. So e to the power of x, differentiation of ex is ex into d by dx of x square. Differentiation of inner function. Formula for ex is being used for e to the power of x square. So we are multiplying by differentiation of inner function. So this is equal to cos e to the power of x square into e to the power of x square into 2x. This can be written as 2x ex square cos e to the power of x square. 2x e to the power of x square. And this. So this is the answer. Now again d by dx of cos log sin x. Now this is cos fx. So minus sin fx into d by dx of fx. So this is equal to minus sin log sin x and d by dx of log x. D by dx of log x is 1 by x. So d by dx of log sin x will be 1 upon sin x. And formula for x is being used for sin x. So we must multiply by d by dx of sin x. This is chain rule. So we are again using chain rule twice. So this is equal to minus sin log sin x into, this is 1 upon sin x and d by dx of sin x is cos x. So we have cos x by sin x. This can be written as cotangent x. So this is the answer. And here d by dx of tangent e to the power of sin x, this will be differential of tangent is secant square, and instead of x we have e to the power of sin x, so we are multiplying by differentiation of e to the power of sin x, and this can be simplified as secant square e to the power of sin x into d by dx of e to the power of x is e to the power of x, so e to the power of sin x will be e to the power of sin x into d by dx of sin x. So this is equal to secant square e to the power of sin x into e to the power of sin x into d by dx of sin x is cos x. So now the question is complete. Here the formula for x is being used for x. So we need not multiply by differentiation of inner function. And even if we multiply by the differentiation of inner function, it will be d by dx of x. So d by dx of x is 1. So it will be 1. And here this is equal to d by dx of cotangent log sin x is minus d by dx of cotangent is minus cosecant square. So instead of x we have log sin x. So we are multiplying by differentiation of log sin x. So this will be equal to minus cosecant square log sin x into d by dx of log sine x. Now d by dx of log x is 1 by x. So we have 1 by sine x into d by dx of sine x. So this is equal to minus cosecant square log sine x into d by dx of sine x is cos x. Cos x over sine x. And this is equal to, now cos x over sine x is cotangent x. Cos x over sine x is cotangent x. So we will have minus cotangent x into this. That is cosecant square log sine x. And this is equal to, now d by dx of secant log xn, not d by dx of secant log xn. So this will be the inner function. So we have secant x tangent x into d by dx of inner function. So this will be secant log x to the power of n tangent log x to the power of n into 1 by x n, 1 by xn into d by dx of x to the power of, and differential formula for log x is being used for log x to the power of n. So we multiply by differentiation of x to the power of n. So this is equal to secant log xn tangent log xn into 1 by xn into d by dx of xn is nx n minus 1. So this is equal to, now xn minus 1 and xn cancel, we are left with 1 by x. So we will have n by x. So here it will be n by x into secant log xn tangent log x to the power of n. And last is d by dx of cosecant 2x square. Now differential of cosecant is minus cosecant x cotangent x. So here we have fx. So minus cosecant fx cotangent fx into d by dx of fx, chain rule. And this is equal to minus cosecant 2x square cotangent 2x square into d by dx of 2x square. Now d by dx of 2x square will be d by dx of ax. D by dx of ax is ax log a. So this will be 2x square log 2 into d by dx of inner function. Inner function is x square. We are using the formula for a to the power of x for a to the power of x square. So this will be the inner function. So this is equal to minus cosecant 2x square into cotangent 2x square into 2 to the power of x square into log 2 into differentiation of x square will be 2x. Now this can be written as, first of all we will write the constant terms. Constant is 2 log 2. Then we write the polynomials. It is x. And then you write the other functions. So this will be 2x square cosecant 2x square into cotangent 2x square. Cotangent 2x square. So this will be the answer. Here it will be a negative sign. First of all you write the sign, then constant, then polynomial, and then other functions. So this is the answer. Now I will take some questions, 2 or 3 questions, because I have already taken the questions in these columns for both trigonometrical functions and other functions. So I will only take 2-3 more questions where chain rule will be used multiple times. Rest I have given you a lot of practice. I have already made you understand how to use chain rule. Now I give you a formal definition of chain rule. But before giving the definition of chain rule, I would like to make you clear how the dash notation is used for differentiation. So first is notation. F dash x stands for d by dx of fx. F dash capital X will stand for d by d of capital X f x. F dash g will stand for d by dg of f g. F dash h x will stand for d by d of hx of f, d by d of hx of f hx. Now using this notation, we can state the chain rule as let fx and gx be two differentiable functions, then f of g is also differentiable. And d by dx of f of g x is equal to f of g dash x is equal to f dash of g x into g dash x. F dash of gx into g dash x. Differentiation of inner function. Differentiate f as function of gx and then take the differentiation of the inner function. Never forget to take the differentiation of inner function. So this is the formal definition of chain rule. I have already given you a lot of practice how to use this chain rule. I will take 2 or 3 more questions and then take the next topic. Now first question is, we are given the function y is equal to under root log sine x cube by 3 minus 1 and we have to find its differentiation. dy by dx. Now dy by dx is equal to d by dx of, now this function can be written as log of sine x cube by 3 minus 1 whole to the power of half. So we have the function fx, this is fx to the power of half. So first we will use the power rule. D by dx of x to the power of n is nxn minus 1. So d by dx of fx to the power of half will be half fx to the power of half minus 1. Half minus 1 is minus half. So this will be equal to half, and this is fx, log of sine x cube by 3 minus 1 to the power of half minus 1, x to the power of n minus 1, nxn minus 1. So this will be half minus 1 is minus half into chain rule states never forget to multiply by the differentiation of the inner function. So this is the inner function. So we multiply by the differentiation of this function. Log of sine x cube by 3 minus 1 we multiply by the differentiation of the inner function, and inner function is log sine x cube by 3 minus 1. So this is equal to 1 by 2 into log of sine x cube by 3 minus 1 whole to the power of minus half into d by dx of log of this. Now again we have log of fx. So we are using the formula for log x for sine x cube by 3 minus 1. Formula for log x is being used for log of fx. So we must use again the chain rule. So we will have now log of x. Differential of log x is 1 by x. So we will have 1 by fx. 1 by fx. Fx is sine x cube by 3 minus 1. 1 by x into d by dx of inner function. D by dx of inner function is sine x cube by 3 minus 1. This will be treated as log of fx. So it is differential 1 over fx into d by dx of fx. Formula for x is being used for sine x cube by 3 minus 1. So we must take the differential of this function. This is the chain rule. So this is equal to 1 by 2, and this function to the power of minus half means under root of log sine x cube by 3 minus 1 into, this is 1 upon sine x cube by 3 minus 1. Here it must be x cube by 3. 3 minus 1 into d by dx of this. Now differentiation of this. Again we have sine of fx. We don't have sine of x. We have sine of fx. Again chain rule will be used. A formula valid for sine x will be used for sine x cube by 2 minus 1. So we must multiply by the differentiation of the inner function. So differentiation of sine x is cos. So this will be cos x cube by 2 minus 1. X cube by 3. X cube by 3 minus 1 into d by dx of inner function. Inner function is x cube by 3 minus 1 is equal to 1 by 2 under root of log sine x cube by 3 minus 1 into cos over this. Cos over sine is, or cos x cube by 3 minus 1 into sine x cube by 3 minus 1 into d by dx of this. Now 1 by 3 is constant. 1 by 3 will be taken out into differentiation of x cube. X cube is 3x square and differentiation of constant is 0. So this is the differentiation. So we can write this as these two cancel and we are left with 1 by 2 under the root log of sine x cube by 3 minus 1 into. Now cos over sine is cotangent. So we can write here cotangent of x cube by 3 minus 1. Cotangent of x cube by 3 minus 1 into these two cancel and we are left with x square. So we can write x square here. So this is the answer. I once again briefly explain you how we proceeded in this question. Now first, this function can be written as this. So this is fx to the power of half. So we use the power rule. Half fx to the power of half minus 1 into d by dx of fx. d by dx of x to the power of n is nx n minus 1. So for fx it will be n fx to the power of n minus 1 into d by dx of fx. Now we have written this term as it is, and here we differentiate log of this. Now here also we have sine x cube by 3 minus 1 instead of x. So formula for x will be used for fx. So log of fx will be 1 by fx. Differentiation of log x is 1 by x. So differentiation of log of fx will be 1 by fx into d by dx of fx. Now this term is written as it is, this is as it is, and differentiation of this. Now again formula for x is being used for x cube by 3 minus 1. So d by dx of sine fx. Sine fx will be cos fx into d by dx of fx. Now this term is written as it is, this is as it is, and here we differentiate this function. So this is 1 by 3 into 3x square. These two cancel and we can simplify and write this as cotangent, and this term has been written here and we got the answer. So this is how we repeatedly use chain rule. Go on using the chain rule till you use a formula valid for x for x. If it is used for fx, go on applying chain rule. Here the formula was used for fx, here again for fx, so we are applying the chain rule. And here the formula for x is being used for x, so the process ends here. Now second and third parts you can try yourself on similar lines. I take up the next question. Now here we are given y is equal to this much, and we have to prove dy by dx is this much. Now dy by dx will be equal to d by dx of x plus under root x square plus a square whole to the power of n. So first we will use the power rule. This is fx to the power of n. So this will be n fx. Fx is x plus under root x square plus a square. This is n fx to the power of n minus 1. nxn minus 1. Formula valid for x is being used for fx, so we must take the differentiation of fx. This is x plus under root x square plus a square. And this is equal to n into x plus under root x square plus a square to the power of n minus 1. This term has been written as it is into d by dx of this. d by dx of x will be 1. 1 plus d by dx of x square plus a square to the power of half. X square plus a square to the power of half. So this is equal to n x plus under root x square plus a square to the power of n minus 1. And this into 1 plus, now this will be half. Now again power rule will be used, and fx here is this much, so we are using it for fx. So this will be half fx. Fx to the power of half minus 1, nx n minus 1 into d by dx of x square plus a square. This is the inner function. and this is equal to n into x plus under root x square plus a square to the power of n minus 1 whole into 1 plus, now this is x square plus a square to the power of half, half minus 1 is minus half. So minus half will mean 1 by 2 under the root x square plus a square to the power of minus half will mean 1 by under root x square plus a square into differentiation of this. Now the power rule for x is being used for x. So the process will end here. So this will be 2x and differentiation of a square will be 0. It is constant. Now these two, and we get this is equal to n into x plus under root x square plus a square whole to the power of n minus 1. This into 1 plus x over under root x square plus a square, and this can be written as n into x plus under root x square plus a square whole to the power of n minus 1 into, this is the LCM, x square plus a square, and this will be under root x square plus a square plus x. Now this is same as x plus under root x square plus a square, x plus under root x square plus a square. This term is same as this. So we can combine it here and we get n into x plus under root x square plus a square to the power of n. This will be n over under the root x square plus a square, and this is equal to n into, now x plus x square plus a square whole to the power of n is y, so we get ny over under the root x square plus a square, and this was the result to be proved, hence proved. Now here y is given to be this, and we have to show that dy by dx is this much. Now if we proceed with the differentiation directly, this question will be complicated. We will have to use the rule for division. D by dx of f over g is gx whole square in the denominator into g into f dash x minus f into g dash x. This rule will be applied, and this will complicate this question a lot. So what we do is we first simplify this function. What we do is we rationalize the denominator. We are multiplying and dividing by this term. What we get is this is equal to under root a square plus x square plus under root a square minus x square whole square, and in the denominator we will have a minus b into a plus b. A minus b into a plus b will be a square minus b square. So square of this will be a square plus x square. A square minus b square. B square will be a square minus x square. So this is equal to, now square of this, a square. This will be a square plus x square. A square plus b square. B square will be a square minus x square. A square plus b square plus 2ab. 2 under root a square plus x square into under root a square minus x square whole divided by, this will be a square cancels with a square, we have x square plus x square. So this will be 2x square. Now x square cancels with x square, and we are left with 2a square plus 2 into under root of a square plus x square into a square minus x square. A plus b into a minus b. These two under roots can be combined. A square plus x square into a square minus x square will be a square minus b square. So this will be a4 minus x4 whole divided by 2x square. This 2 will be common and cancel with this. So what we get is a square plus under root a4 minus x4 whole divided by x square. Whole divided by x square. Now we differentiate this. This function is a lot simpler than this function. Now at this stage we carry out the differentiation. What we get is dy by dx is equal to. Now we will use the formula for d by dx of f by g. You can see the side sheet. First what we do is we write gx whole square. So first we write x square whole square. Gx whole square into gx. Gx is x square into d by dx of fx. Fx will be a square plus under the root a4 minus x4. Gx whole square and gx into f dash x minus fx. Fx is a square plus under root a4 minus x4. This into d by dx of gx. Gx is x square. Gx square gx into f dash x minus fx into g dash x. X square into differentiation of a square. A is constant, so differentiation will be 0. This is 0 and this is a4 minus x4 to the power of half. So this will be 1 by 2 into under root of a4 minus x4. This will be a4 minus x4 to the power of half. So this will be half. A4 minus x4 to the power of half minus 1 is minus half. So we can directly write 1 by 2 root x. Differential root x is 1 by 2 root x. This into d by dx of inner function. D by dx of a4 minus x4. So this term is complete. Minus a square plus under the root a4 minus x4 into d by dx of x square is 2x whole divided by x to the power of 4. If we take x common from here, this will be common and will cancel with this and we will be left with x cube. So what we get is x into this. So x into this. This will be x divided by 2 under root a4 minus x4. X into this into d by dx of this. Differential of a4 is 0 and differential of minus x4 will be minus 4x cube. We have x cube in the denominator. Minus, now this term has been simplified into this minus, now we open this bracket. We have minus 2a square minus 2 under root a4 minus x4. Now I have noted down the last term from the previous page. You can see the side sheet. Now this can be simplified as we first take the LCM of numerator. We first take the LCM of the numerator. So this will be 2 under root a4 minus x4 and this term is x cube. So LCM of this we will get minus 4x to the power of 4 minus. Now this term will be minus 2a square into 2 under root a4 minus x4 and this term will be minus 4 into a4 minus x4. After taking the LCM, we get this term. This is equal to minus 4x4 minus 4a square under the root a4 minus x4 minus 4a4 plus 4x4 whole divided by 2 under root a4 minus x4 into x cube. Now these two terms cancel. Now minus 4a square is common. So what we get is minus 4a square is common. We get a4 minus x4 under the root plus a square. 4a square is common. So we will get plus a square divided by this. So we get minus 4a square is common. We are left with this plus 4a square is common. We are left with a square over 2 under root a4 minus x4 and x cube has been written here. Now what we see is in the question we have to prove that dy by dx is equal to this much. That is, we have to take 2 cancels and we have to take minus 2a square by x cube common. Minus 2a square by x cube is common. So we get minus 2a square by x cube is common and we are left with this cancels with this 1 plus a square over under root of a4 minus x4. This is common and we are distributing it inside the bracket. So we get 1 plus a square over a4 minus x4. You can try this question yourself on similar lines.